Beyond single signals, a new statistical approach to finding alien life for decades, the search for extraterrestrial life has focused on finding a smoking gun single, unmistakable chemical or physical signal on a distant planet. However, a groundbreaking study suggests we may have been looking too narrowly. Instead of hunting for individual biosignatures, scientists are proposing a shift toward identifying large-scale planetary patterns across entire star systems. The problem with traditional detection, current methods of astrobiology face two significant hurdles that often lead to scientific uncertainty. False positives. Many biosignatures, such as specific atmospheric gases, can be produced by geological or chemical processes that have nothing to do with biology. Assumption bias. Technosignatures, signs of advanced technology, rely heavily on the assumption that alien civilizations will behave or use tools in ways similar to humans. Because of these issues, a single discovery is rarely enough to confirm the existence of life. This creates a signal versus noise problem, where it is difficult to distinguish a living world from a chemically active but lifeless one. The concept of agnostic biosignatures. To bypass these limitations, researchers from the Institute of Science Tokyo and the National Institute for Basic Biology have proposed a method called an agnostic biosignature. Unlike traditional methods, an agnostic approach does not care about the specific chemistry of life. It doesn't matter if alien life is carbon-based or something entirely different. The method looks for the effects life has on its environment. The research is built on two core premises: panspermia, the possibility that life can spread between planets within a system; environmental modification, the tendency of life to gradually alter the physical and chemical properties of its host planet. How the method works. Finding patterns in the chaos using agent-based simulations, the research team led by Associate Professors Harrison B. Smith and Lana Sinapayan modeled how life might migrate through star systems and reshape planetary environments. Rather than looking for a specific gas on one planet, they looked for statistical correlations. If life is spreading and modifying worlds, it will create measurable links between a planet's location and its observable characteristics. By focusing on how life spreads and interacts with environments, we can search for it without needing a perfect definition or a single definitive signal, says Harrison B. Smith. Key advantages of this approach include reliability over completeness. The method prioritizes reducing false positives. While it might miss some inhabited planets, it is much more likely to be correct when it identifies a candidate. Efficiency. In an era where telescope time is extremely expensive and limited, this statistical clustering helps astronomers decide which planetary groups are most worth investigating. Universal application. Because it looks at patterns rather than specific chemicals, it remains valid even if alien life is fundamentally different from Earth's biology. The road ahead, while the study is currently based on simulations, it establishes a new framework for future space surveys. To make this method a reality, scientists must first build a more robust baseline of what lifeless planets look like across the galaxy. Only by understanding the natural diversity of dead worlds can we accurately spot the subtle, large-scale patterns left behind by living ones. Conclusion: by moving from a micro view of individual planets to a macro view of planetary populations, scientists may finally overcome the ambiguity of traditional biosignatures. This shift suggests that the signature of life may not be a single chemical fingerprint, but a detectable pattern written across the stars.